Okay, so my subsystem is focused on trying to turn the spectrometer data that we're getting from our testing into that calculated iron content using some sort of computer model or web app. So to kind of go into that a little bit more, this is kind of the data we'd expect to see. Basically, a column for wavelength, a column for absorption, and just a ton of values. So this data set is one I found online. I wanted it to be nice and messy, which is why I didn't use one of our testing things because I wanted to see if I could break the model in any way. So this is 4,000 data sets. This is about what you expect. The wavelength that we're probably going to look at and run for these testing is going to be a lot more narrow than this. It's probably not going to be this large of a data set, but this is good for testing the model and making sure that it works for any sort of situation. So with that in mind, again, this is the data set you expect for an IR, and this is how we're going to analyze it. So this is R. It's a basically a statistical analysis program, kind of very similar to Python if you've ever used it before. And this is what we're going to use to kind of calculate our content. And this is basically the gist of how we're going to go about doing that. So I'm going to graph the data. So this is kind of the data set that we'd expect to see. We expect iron 2 plus to be around this peak here. And this is what I'm going to use to kind of pretend like this peak is the iron 2 plus, even though I'm pretty sure it's not actually in this research paper. But we're going to look at this range to try and identify this peak. In order to do this, is this equation here. So what this does is that it makes a subset of from 1050 to 1070 nanometers, is where we expect iron 2 plus to be around, and it selects basically the absorption value. So it selects makes a sample of those source values, and then it finds the maximum value of that within that range, and that's going to be our maximum absorption peak. And what we can do with that absorption peak is we can use this equation here, uh, and I'll go into how we create this later, and we'll get the iron concentration. So in this sample, we're expecting the iron 2 plus concentration to be about 0.0167 molarity, just because that's the data set we were given initially was in molarity. So this equation here is basically a linear approximation of Beer's law, and as we've kind of discussed before, and this is kind of how we generate this is this equation here. So this is kind of how we create our model. I created this equation off of just random data. So this is the data that I made up. It really is just absorption for our iron peak versus a known concentration. So what this will actually look like when we have our testing in and when that's all good to go is this is going to be known values that we know, and then the measured absorption. We're going to use that to create a linear approximation of Beer's law for our sample set and our testing procedures, and we'll use that to create the model. But since I'm just testing the model, this is really just made up data. So to kind of do that, we have this linear approximation here. This is going to spit out this information here in you can see in the console. So this gives you a ton of statistical things that you can look at, how good our fit is, how good these variables are, these kind of coefficients, if they're any kind of statistically relevant. As we can see, the absorption, this value here, kind of where we're multiplying absorption. This kind of linear approximation of the basically our kind of Beer's law again, and this would be kind of an adjustment for anything going on in a machine, kind of the oil, whatever is going on that's not just within the glass and the iron that we're looking at. So this is kind of how we summarize it. It gives us a standard error that we can kind of use to predict how far off our model is going to be. It gives us an R-squared value. Now, what we want to do with that, we can look at exactly how well does this model line up with our data. It lines up pretty good. Generally, this looks like a pretty good line. Again, it's completely made up, so this is not what going to be what our actual model looks like. But the big thing that I'm showing off is these four equations here. So these equations, as you can see down here, these all calculate this is how we're analyzing and testing our model. This kind of calculates how well we have a fit, and basically we want these values to be a bit smaller. Um, and when we're in an actual model, this is going to tell us how good our model is and if there's any standard error within our model and what we can explain that as. So if we need to change any testing procedures, this is where you're going to see it through these values here. So yeah, now this isn't very approachable for a plant user whatsoever, right? Like this is coding, you have some experience doing this, which is why I made this plot, this program here. So this uses the library Shiny, as you can see up here, and it creates basically an app. How this works is that it takes basically everything I just showed you and it puts it into HTML text that's easy to use. So if we run this, um, we get this nice little opening here. So this is the app. I have a CSV of the data I was talking about before over here. If I copy that in there, bam. You get everything that you expect. So you get a table and you get the sample spectrometer data so the operator can see what's going on. And we also get the ion concentration calculated just about here. So this all works internally with the app. Um, this kind of header option is in case you have, if you have, as within the data set there, wavelength is a low option. Sometimes you'll see a lot of data sets that don't have this. So you would uncheck this box and it would put these first two values in there. This doesn't work for this because it does have the heading, so we're going to keep that checked and it's going to update. So the value of this is that you can then distribute it to many different places. So what I've done here is I've put the application online. This is the easiest way I think to kind of make sure it's equally spread out across your plants. So this is the application. So this uses shinyapps.io. It's a completely free software. You just create an account and you can put whatever you want onto this shared link. So this link should work for anyone and it's the exact same app.